This video tries to give you an overview or a little bit of a hint on how to implement the requirements of the Engineering 250 Design Lab number 6. The goal here is for us is to learn the knowledge we have on finite state machines and all that we've learned with respect to the design process and implementing and testing a system with memory to build a three-way intersection, but this time in just not going from green to yellow, but rather you're going to go from green to yellow, then to red. So we used to go from green to red automatically without having that yellow caution in the middle. So now we're going to create that, which means that our timing diagram would be more like this. When a green goes away, when the green goes from being lit to not being lit, and then we need to, as soon as the green goes away, we need to turn the yellow on, and then after 2 to 4 seconds, we need to come back around and turn the red back on. Okay, so that's our goal. And in the process of kind of learning this and moving forward with it, we're going to start introducing some parts. We're using the 74HC74 here for this exercise. A D flip-flop, it's basically a D flip-flop. If you want to read about it, this explanation is here. All the pin numbers and everything is in here. Then you can use that as a first pass to do this experiment. So let's go ahead and see if we can figure out how we can do this. We can go ahead and start by learning how we can create a delay. So if we have a clock, now the question is, how do we build this clock? Just go back to one of your previous lab experiments like lab 4 or 5 and learn how you can use a 555. You can use a 5-5 timer, the circuitry is there, and it creates the clock for you. So you've got the clock, and that's basically that clock set for 2-second periods. And then since we're using 7474, HC74 for flip-flop, we'll get 2 of these flip-flop. One we're going to call D1, Q1, and the other one we're going to call D2, Q2. And if you have the clock, so they have a place for you to put the clock. So we put the clock right here. And then if I put anything in here, let's watch what happens when it gets to the out point, okay? So if you think about what happens is that the D is not seen by Q. So let's say the in circuit, let's say make a transition from low to high right here. And leave it. That's the only thing we're interested in. The low will happen the same way, but once we understand one end, we can understand the other. So now you want to think about, okay, what happens on Q? Since this is a rising edge thing, we know, we flip-flop, we know that nothing will happen except on the rising edge. So only these are the places things will change, right? On the rising edge. So basically what happens is that my Q1 will change at this point because the flip-flop hasn't seen the input until the rising edge of the clock comes along. So that's what we're going to see. So now the question is, how long is it from here to here? We know if this just went away, when it came on right after the rising edge, or immediately after it, then it would take almost 2 seconds to get there. So the time here, it depends on where it changes. It will be somewhere between 0 and 2 seconds to get this thing done. That's not enough because if you remember, you wanted 2 to 4 seconds. So now if I take the Q1 and put it to D2, what's going to happen? Q2 now, this input is not going to be seen by second flip-flop until the second rising edge. So that means that Q2 will change. Q2, which is also, we call it out, will change at this point. So it will change right here. So now the question is from the time the original signal changed till the time where the Q2 or out changed, now it's going to be not 0 to 2 seconds for this, and then the whole clock cycle. This period is always 2 seconds. because it was immediately after the rising edge change. So it's going to be immediately after the next rising edge changes. So this will be 2 to 4 seconds. Oh, that's exactly the delay we wanted. So, okay, great. So now we built this module, which is basically this module, okay? And all it does is if you put an in there, it'll give you, so we'll call this one the delay circuit, so we don't have to remember how to build it anymore. So we'll build a delay circuit. When we put it in, then the out will be basically 2 to 4 second delay. Whatever in does 2 to 4 second delay later, that does it. So this is our delay circuit. We're perfect. So we build that, that's all good, and we're done. Now, how are we going to use this? How are we going to use this to figure out, to build a three-way intersection, how to build a three-way intersection that has both, so we'll have a green light for each lane, we'll have a yellow, which I don't know if I have a yellow. Yeah, there's a yellow. It won't let me put yellow lights out. I'll put a yeah. And then a red light here. Somehow it's not letting me put a yellow light here. It kind of. All right. So let's say, well, I'm going to make up a color. Let me see if I can make up a color here. I'll just use something slight. Maybe use blue. Yes, imagine this is yellow here. Okay, so you have the three lights. And what you want to do, you basically want when the green light goes away, you want 2 to 4 second delay before I'm sorry, so you want the yellow light to immediately come on, stay on for 2 to 4 seconds, okay, and then you want, so this would be the yellow light, and then you want the green, the red to come on here. So perfect. So what do I need to do? So for each one of the lights, for each lane, when you're building the line, remember, in earlier, you had a circuit in lab 3 or whatever, you build a circuit where it gives you the priority of, and then you would have 3 lines coming on. You would have a green, you will have a west, which would be west green. You will have a south green, and you would have an east green, basically lights that would start to come up, okay? So now you can't use that because used to, your previous case, when green went away, red immediately came on. You can't do that anymore. You want a delay in there. So all you have to do for each of these lines, you have to create this for each of these lines. You can't just do one and reuse it. So you've got to create the same circuit for each one. So let's say we were trying to build a green west, yellow west, and red west. So all we're going to do is, if you want to do, we're going to use the circuit we learned earlier, and we're going to try to build this system that allows us to do that. So let's go ahead and see if I can move this up. All right. So what we're going to do, we're basically going to say, look, I have my delay circuit. So if I take the green and run it to my delay circuit, so I'm going to take the west green that came from lab, whatever the previous lab was that we built, the circuit without the thing. I'm going to take the west green and I'm going to put this thing through. So we're going to go put it through the delay circuit we just built just a minute ago. Then I'm going to get delay west green light. So what's that? That basically the delay west green, all it's going to do is going to, instead of going down here, it's going to go down right here. So that makes our life really easy. So basically it says, I want a yellow, I'm going to build yellow by taking the green west, the permission to go green from the previous lab work we had done, and I'm going to AND it with the delayed west green. So during this period, it's going to be high. Everywhere else is not going to be high. Of course, this is a not this one plus that one. And when is it red? Well, it's going to go red when both of these guys are not. So basically the red would be green west, and it would delay west green. Great. So we build the red west, and we build the yellow west. Now the question is how we get the green west, because this west green is really not our green yet. So what we want to do is how can we make the light go? So for the green light for west to go on, it has to make sure that your west green is on. So this has got to be west green has got to be on, and both red south and red east. So both of the other ones have to be red before you can go green. Okay, so that would be the circuit you need in order to turn the green light on. Okay, so now what's going to happen is that when you want to go green from the priority circuit you built in earlier labs, you can't just turn the green light on. You have to first create the yellow, then you got to create the red, and then you got to check the other two lanes to make sure they are red before you can go ahead and turn your light green. So this kind of gives you an idea of what you need to do. Once you build one of the lanes, then you can pretty much mimic the same process to build it for the other three lanes. Once again, when you do this schematic, make sure you have a very clean system diagram showing what the inputs and the outputs are. Show the circuit schematic with all the pin numbers and parts you've used and everything else, so it's clean and easy for folks to see it. Now, if you want to make your life easier, it's a little bit easier, not that much easier, is instead of using a 7474, which has only 2 flip-flop and you got to use 3 parts, you can go ahead and use 274 or 374 right here, which is, I believe it's got 8 of them. So you've got plenty for everything you want to do. So it's got 8 D flip-flops in it. So you don't have to use 3 parts. You can just use 1 part. And either way works just the same. Just if you want to be a little more efficient, you can use this. Hope that's helpful. Let me know if you have questions that arises from this. This was meant to give you a little bit of a preview of how you do this. Now, this was kind of a shortcut and a modular way of doing it. If you want to go the full way, you can. It just takes a lot longer. In other words, you can go ahead and do the state diagram, and then the next step, go through and do the present state, next table, and then do the schematic based on those, much like we learned in the classical design of synchronous machines. It just takes a lot longer to do that. This way, you're leveraging from the work you did in the previous lab, when it was just deciding if it's time to go green or not time to go to green, but kind of selecting the priorities in earlier labs. You take that plus the 5-5 timer, just build one delay for each lane, and you can create your circuit that way. And it would be a little bit faster to do it that way. Hope that helps. And again, just let me know if you have any questions. Take care. Bye.